So, yeah, this is the part.
What goes into 72?
Sorry. You guys work it out? Yeah, you just have to correct. Okay, now I'd like you to turn a different direction. If you were turning side to side, turn front or back. Find a different partner and see if you guys come up with the same thing, or if you're totally lost, what your neighbor got.
Oh, yes. So, answer is I'm going to talk to the clowns.
Okay, finish your conversations, please, in 5, 4, 3, 2, 1. Who thinks they're confident at finding the prime factorizations of negative 72? Okay. Jeff, I guess it's all you. What did you do, Jeff?
I did 8 and negative 9.
Okay.
And then I split 8 and it's 4 and 2.
Can I just go to 2, 2, 2? That trick?
Yeah, that's fine.
Okay.
And then for negative 9, I did negative 3 and 3.
Okay. Anyone else do it differently, other than having different numbers for 8 and 9? Did anyone have the negative end up on a different number? Did you have it end up on like a 2 instead of a 3? Yeah. Yeah, so to get around everyone getting different answers of where the negative could go, at the beginning what we're going to do is actually make that a positive 9 and pull out a negative 1. So I'm going to make that a positive. So otherwise, people could put the negative on the 3, or they could put it on the 2's. But negative 1 is negative 1 prime. Can be divisible by 1 in itself only.
Yeah.
Yeah. So it still works as its own prime. So these are primes, and negative 1 is a prime. So that's the trick with that one. We're going to pull out a negative 1 at the very beginning. Everything else will be positive. So what's the smallest base? 2, 3, or negative 1?
Negative 1.
Negative 1 is the smallest base. So there's only one of those. Times, the next smallest base is
2 to the third.
2 to the power times
3 squared.
3 squared. Okay? So example 3 also has a negative. With your partner, try to factor out example 3, knowing now that we pull out a negative 1 at the beginning. Feel free to talk to your neighbor about the math, not other stuff, please, but about the math. Factor it together. You two should be talking about the math. Together. Yes, work together. First I have to draw an upside down piece. That's usually the first step, right? And then do that first step we just did on example 2. Okay? So all 3 of you should be talking to each other. Now talk to your neighbor. What does he think you should do with those variables? We'll factor out or find the prime factorization of negative 36. Okay, so do that for now. You work on the negative 36. If the variables are throwing you off, just work on the negative 36. Gosh. Good job. Excellent. We have a winner. Okay. You're really warm. Halfway there. You got the numbers down. What about the rest? There you go. Good job. If you've gotten it, turn around and help your neighbors. Okay, what about those variables? What do you think happens with those? So what two numbers multiply to negative 36? Tyson, will you share what you've done at the beginning? That's good for the numbers so far. So share with your neighbor. Okay, now 6 is prime. Everything else was good, especially the variables, you got that. But 6 is not prime, so you need to do all those 6, right? Okay, example 3. Someone I haven't talked to yet. Omar. Since there's a negative, what's the first thing we should pull out? Negative 1. Great, Omar. And then tell me, Omar, two factors of positive 36, since I've already pulled out a negative 1. That two numbers have a product of 36. 6 and 6. Good. Okay? And how does 6 break down? Is it Alexis? Great. Yeah, Alexis. 2 and 3. So both of them will have identical factors. 2 and 3. Okay? And then what we do normally, or on those ones on the left, we would find the lowest base, which is the negative 1, times 2 squared times 3. But this time we have variables.
3 squared.
Is there any point to breaking down those variables? Oh, what did I do wrong? Oh, thanks. Is there any point to breaking down those variables? We break down the x squared, it's just going to show us that we have how many x's?
2.
2, and then we just write it as x squared. So there's no point to breaking them down. You just attach them at the end. X squared, y. Okay?
Do you do like times x times y? That's what I did.
No, because prime factorization would use the exponents of how many if there's repeated multiplication. Okay, let's go through and fill in the first two columns. 1 through 12. 1 squared, 2 squared, all the way through 12 squared. No calculators, though. No calculators. Fill in both columns. 1 squared, 2 squared, 3 squared. 1 squared means 1 times 1. What's 1 times 1? Okay, write it in. Go all the way through 12 squared. But it's not 3 times 2, it's 3 times 3. Squares mean you repeat the same number. So it's 1 times 1, and then 2 times 2, and then, yeah, it's 3. So this means 3 times 3. That's 3 times 3. Yeah. And the next one will be 4 times 4. So just keep repeating multiplication. Okay, I can see a lot of people need their names on their papers. Would you put your names on your notes? Remember, notes are turned in the day of the test, which we just wrote on our calendars coming up. Okay, 7 times 7, 7 squared, all the way through 12 squared. Fill all of them in, please. These are ones you should know, or you should start to memorize if you don't know them. Because they're probably used. 1 squared. It's 1 times 1. Go ahead. Okay, what we're going to do is kind of like a choral response. Your row at the same time will answer the one I give you. And when I go like this with my hands, that means you should respond at the same time instead of one person here, one person there, one person there. Like in choir, we'll all sing at the same time, as a group, as a section. Okay, so starting with the back two guys in that back row. 1 squared is, okay, we're not, we failed at choir. Let's try this again. 1 squared is, a little better. Okay, and we need some enthusiasm with this too. Third row, 2 squared is, okay, thanks Skylar. The rest of you, 2 squared is, okay. So, third row or second row right here, do you know what you're doing? Okay. 3 squared is?
Good.
Okay.
Yeah.
Maybe by this row we'll get it. Okay, at the same time, with enthusiasm, and the correct answer, when I go like this, you respond. 4 squared is?
16!
Oh, thank you.
Yeah.
Okay.
Teamwork.
Teamwork. Okay. 5 squared is?
25.
Good, we got 2 in a row with enthusiasm. Quarter response. 6 squared? Good. Okay, we're improving. This is improvement. 7 squared? Oh,
Oh.
It died.
it died. It's like the wave at a basketball or football game. All of a sudden, it comes to one section that died. Okay, so that was 7 squared. So 8 squared is? So yeah, 8 squared is? There we go. Now we have everyone. Okay, back over here. Time to redeem yourself. 9 squared is? Okay. 10 squared, third row. Redemption's right here. 10 squared is?
My drink.
Skylar still wins again and in first. Okay. 11 squared is?
Yeah.
And make it good, guys. 12 squared is?
144.
Thank you.
Your voice.
If you didn't know some of those, time to start memorizing them because they're useful to have in your memory bank. So we use them a lot. Okay, everything has inverses. With equations, when you solve for x, we use inverse operations. Who can tell me the inverse of addition? Subtraction, because when I add $4 to your bank account, if I change my mind, I would subtract $4 from your bank account, right? Alice in Wonderland, who's seen the movie Alice in Wonderland? That was written by a mathematician, Lewis Carroll. His pseudonym, that was his fake name. His real name was Charles Dodson. It was written by a mathematician. Who knew that? So if you read the book especially, there's lots of math in there. Especially my favorite is when they're all at the Mad Hatter's birthday table. Very happy birthday to you. You know that song? Me too. And they have to like move down. There's like a math formula you can figure out which seat will end up. Anyway, so when she's like following the bunny, the rabbit, I guess, and she gets to, I think it's first she gets to a door that's too small for her, right? So how does she get through that little door? She doesn't just subtract in size, she like divides herself down, she drinks a potion or something. And then she's like, oh no, I left the key up on top of the table, I can't reach it now because I'm too small. So then what does she do to undo the dividing of her size? She eats like a cake, and it multiplies her size back up, and then she grows too big and she takes out the door with her foot, and then something else happens. I don't know. She starts floating on water or something. Okay, so multiplication, division, inverse operation. Same thing here. If we square, we have an inverse. What undoes squaring? Oops. Besides whatever I just did. Square root. So we're going to undo it. The square root of 1 is 1. Square root of 4, 2 squared is 4. The square root of 4 is 2. The square root of 9 is, and you'll see they just go in order all the way to 12. Square root is the inverse of squaring. It is beautiful. Math is beautiful. Okay. Now for simplifying the following radicals. Example 4. Simplifying radical means factor tree. See what you can pull out. Make sure you know what the directions tell you. And actually, number 1, make sure you read the directions. Some people don't read directions. And then you end up doing the wrong thing. So if it says simplify, that means break it down. Find those pairs. If the index is 2, find the pairs and see what you can pull out. So with your neighbor, please simplify square root of 2, or 24. Square root of 24. With your neighbor, factor tree it out. Find pairs that can pull out, because square root has an index of 2.
Why do you have a creepy combo?
You don't like clowns?
No, it's just kind of creepy. It's like an old man baby.
I want it.
Doing what?
my old school had random raffle drawings. It was usually confiscated stuff from students. Until one year I got like a whole thing of random pens and necklaces and stuff. And so this year I had the option to choose, and there was that clown bell, so I chose the clown bell. It's actually really obnoxious. I was with all the other confiscated stuff, so
Or they like confiscated it for like
yeah.
Maybe they confiscated it for being annoying.
Okay. Route 24. Kevin, what did you first break it down with? 12 and 2. Now you may have done 6 and 4, but your end result will be the same, or 8 and 3. And 12 breaks down to what, Kevin? 6 and 2, and 2 is 2 and 3. So then we take all of these, and you can reorder them for your convenience because of the commutative property of multiplication. Lets us commute them to a different order. And what are we looking for? Yeah? What are we looking for? Yeah, say it louder. That's exactly right. So pairs. Matching pairs. So because right here, if the index isn't written, it's automatically a 2. It's a square root, and the number 2 represents square. So we have one pair. What about these guys? Can I pair those up?
yes. No.
No. Why not? Nico?
1, 2, 1, 3.
Yeah, they don't match, right? Yeah, so they don't pair up. So I pull out a 2 because of this group of 2's, and then 2 and 3 don't match, so I times them back together, which makes 6. So that's simplified. Okay, with your neighbor, please go do example 5. You can do the variables. Don't let variables freak you out. You can do them.
Oh my.
You know what? I don't actually know. You can times it out. Or you can times it out. Right hand. Okay. And example 5. You're working on it. Break it down. Now, if you're having a hard time with 128, realize it's even, so that should give you an automatic number you can divide by. You don't have to divide by this number, but it works. Ah, nice. Now find the pairs. Okay, I'm going to give you about 5 more seconds. 2, 1. Yep, see, I told you. Okay. Since it's Monday, we're short on time, so let's go through it really quick. You could break this down into tons and tons and tons of 2's, right? Does anyone find a different route besides the 2's? What do you have?
32 and 4.
32 and 4. Let's see. 2 times 4 is 8. 3 times 4 is 12. Works. Okay? And then we could break down the 32 into 8 and 4, right? Could I claim that this was a pair instead of breaking it down to the 2's? Because a 4 and a 4 is still a 4. Otherwise, I get 2 pairs of 2, which is still 4. So if you see a match right there, you can keep it. You don't have to keep breaking it down. And then I have another pair of 2's. So we have a pair of 2's that pulls out, a pair of 4's that pulls out, and this guy is the only thing that doesn't come out. So negative 2 times I pull out a 2, I pull out a 4. Remember when you pull it out, it's a multiplier. Square root 2, and there's 2 x's and a y. What do I do with those variables? Yep, we have a pair of x's too. So let's multiply these out. Negative 2 times 2 is Negative 4 times 4 is negative 16. We pull out that x, root 2y. Okay, on the back side, if you have it back, we're doing example 10. If it's blank, we're going to write down example 10. Some of my copies kind of look funny, and I figured we'll just write it if it wasn't there. Okay, example 10, this guy says, I'll write it larger for those in the back. Cube root of negative 16a cubed. Please show me with fingers in the air. What is the index this time? Fingers in the air. What is the index or grouping? 3. Good. So we're not looking for pairs. We're looking for 3 because of this number right here. All right. With 16, negative 16. The reason I want to show you this is because how does negative 16 break down? Okay. So I hope you're using pencil on this one. Negative 1, 4 and 4. And then 4 is a pair. Can I do pairs when our index is a 3? No, I can't. So I have to go down to 2's. So I have all these 2's and I find a triplet. But it leaves this negative 1 underneath. I said I hope you're using a pencil for a reason. With a little manipulation, we can get the negative out front. Because you're okay. 3 more minutes, man. That's all I have to survive. I'm going to manipulate a little bit. If I do 8 and 2, oops, one of those has to be negative. Make that one negative. Is it true that this many negatives would also be a negative? 2 times negative 2 is negative 4, times negative 2 is positive 8, times negative 2 is negative 16. So it's still negative 16, yes? And I have a triplet of negative 2's. So I can pull out a negative 2. Also, I can pull out an a and root 2. So we want to try to look to pull out that negative if we can, which is, I know, different than how we just did prime factorization. Okay, next time as a reminder, we'll be in the computer lab. Let me pass out your homework, which is a worksheet. You should be bringing questions on these radicals and prime factorizations next time. Also, due next time is page 48. It's already hole punched for you. Take one, pass it down. Make sure you're aware that there are 2 sides on it. Really? Those who have those disclosures that I returned to you, please bring those next time or stop it tomorrow until this week. If you put an Arizona monster drink or whatever that is on the back counter, please pick it up on the way out. I don't want a whole collection of those. Oh! One more thing I should say. Everyone have a seat, please. Tutoring starts today. Yes. Day after school, right behind this whiteboard, room 100A. Right behind me. Okay? They have tutoring. They're going to have tutoring Monday, Wednesday, Friday until 3:30. If you live in South Salt Lake, there's a late bus that will pick you up at school at 3:30 and take you home. If you live in the Benyon Taylorsville area, there's a 4:30 late bus. Not that many kids can graduate